Good day. Today I'm going to discuss all about Y-bus admittance matrix. So the equations used to construct the Y matrix came from the application of Kirchhoff's current law and Kirchhoff's voltage law to a circuit with steady-state sinusoidal operation. These laws give us the sum of currents entering a node in a circuit is zero and the sum of voltages around the closed loop starting and ending at a node is also zero. These principles are applied to all the nodes in a power flow system and thereby determine the elements of the admittance matrix, which represents the admittance relationships between nodes, and which then determine the voltage, currents, and power flows in the system. And in order to obtain the node voltage equations, we consider a simple power system which our impedances are expressed in per unit on a common MVA base. Sometimes for simplicity, resistances are neglected and impedance are converted to admittance. To make it more clear, let's have an example. Okay, next. Here, suppose we have bus 1 right here, and bus 2, bus 3, bus 4. The line here that connects bus 1 to bus 2 or buses to buses, the line between them are what we call the transmission lines. Each transmission lines have an admittances, have an impedance. Okay, bus 1, let's say bus 1 and bus 2 had some sort of generator that connected to it. Then here, there's a generator connected to them. Then there's a transmission line that connected bus 1 to bus 2. Now, uh, bus 1 to bus 2, let's say we have an example, we have an impedance J 0.4. We all know that impedance is expressed by Z. Z is equals to R plus JX. As we can see from the example, there's the resistive component here. It's all reactive component, so let's keep in mind that this is just an example. Okay. So the admittance of this transmission line is equal to the Y. Y is equals to 1 over Z. The Y is the admittance, the Z is the impedance. So based from our example, our first admittance is also equals to 1 over J 0.4, or as calculated is negative J 2.5. Okay, then let's put some values to other admittances, to other transmission lines. Let's put some admittances value. So we have the formula I, which is the current, is equals to Y bus times V bus. Y bus is equals to the matrix of all admittances here in our example. But first, let me tell you the elements of each admittances. We have the diagonal elements such as y, y11, y22, y33, and y44. They represent the admittance of a particular bus. It is essentially equal to the sum of all the admittances connected to a bus. Like for example, in y11, we have admittance y10, y12, and y13. The, the summation of all of that, those three, are equals to y11. And similarly to y22. Y22 is the sum of admittances that is connected to bus 2. Here we have bus 2 here, and the admittances connected to bus 2 is the y20, y12, and y23. Also, in y33, the admittances connected to bus 3 are equals to y33. And y44 is the sum of admittance that is connected to bus 4. And in bus 4, we have y34 since this is the only admittance connected to bus 4. This 4 is what we call the diagonal elements. And the rest, the y12, y13, y14, y21, y23, y24, y31, y32, y34, y41, y42, y43, they are the negative multiplied by the admittances that spans from this bus, like for example from this bus to this bus, from bus to buses. Like for example in y12 we have the negative of its value. Then we have j2.5. Okay, using the Kirchhoff's law at bus 1, at node 1, we have I1, the current flowing in the bus 1 is equals to admittance y10 times the voltage from the bus 1 plus y12 times the voltage from the bus 1 minus the voltage from the bus 2 plus the y13 times the voltage from the bus 1 2 minus the voltage from the bus 3. At node 2 from the bus 2, we can see the current flowing here. Then we can have I2 is equals to y10 times V1 plus y12 times V2 minus V1 plus y23 times V2 minus V3. At node 3, bus 3, we can see that there is no current flowing here at bus 3, so we can say that we have 0 current, so 0 is equals to y23 times the voltage from bus 3 minus the voltage from bus 2 plus y13 times V3 minus V1 plus y34 times V3 minus V4, and lastly we have bus 4, and also there's no current flowing here at bus 4, so we have 0 is equals to y34 times the voltage from the bus 4 minus the voltage from the bus 3. Okay. This diagonal, as I have said earlier, is the diagonal element admittance, and the rest are the off diagonal. Y11 is equals to Y10, Y10 plus Y12 plus Y13. As I've said earlier, the diagonal elements represent the admittance of a particular bus. It is essentially equal to the sum of all the admittances connected to a bus, which means to say that is the summation of the admittance connected to its bus. From the bus 1, we have 3 admittances, the summation of those 3, summation of these 3, and then in bus 2, we have Y22. These 3, the summation of these 3 is equals to Y22. For Y33, we have Y13 plus Y23 and plus Y34. Y44, since the Y34 admittance is the only admittance connected in the transmission line between bus 3 and bus 4. So we have Y34. We can use this formula to make it easier. Okay, here we have Y12, this is the off-diagonal element of admittances. Okay, the Y12 is equals to is the reciprocal of its admittance, which is Y21, then it will become negative Y12. Y13 is equals to Y31, then negative Y13. Y23 is equals to Y32 is equals to negative Y23. And Y34 is equals to Y43 is then equals to negative Y34. Okay, let's input the given values from our examples in our equations I've set for this slide. Okay, in Y11, we have negative J1 plus negative J2.5 plus negative J5. In Y22, we have negative J1.25 plus negative J2.5 plus negative J5. In Y33, we have negative J5 plus negative J5, and then negative J12.5. And in Y44, we have negative J12.5. And for the off-diagonal element of the admittance, we have Y12. The reciprocal of this negative J2.5 is J2.5. Y13, here, negative J5, then we have J5. Y14, 0. Y21, J2.5. Y23, J5. Y24 is also 0. Y31 is J5. Y32 is J5 also. And Y34 is J12.5. the y41 is equals to 0, and also the y42. Y43 is the reciprocal of this negative j12.5, then we have j12.5. Simplifying this formula, we have the summation of these three admittances is negative j 8.5. Then this y22 is equal to negative j 8.75 from y33 negative j 22.5, and y44 is negative j 12.5. Then that's it. That's our Y-bus matrix, admittance matrix. Thank you for listening and watching. God bless.